Good afternoon. I am Sandeep Methani and I work in the Urban Regional Studies Department at Indian Institute of Remote Sensing. Today I will be discussing with you my views on the urban sprawl and urban growth modeling. As we know, urban areas contribute to nearly 70 or 75% of the country's GDP, and they are the driving engines of our nation's growth, economic growth. But what is associated is with this growth we are also having some ill effects also. So urbanization is very necessary for the development of the country, but what is now necessary is that urbanization should be done in a sustainable manner. So the emphasis should be on sustainable urban development. Urban growth is basically a very complex phenomena in which we have a number of factors which are interacting with each other at the local or the micro level in a non-linear fashion to generate a pattern at the macro level or at the gross level that is more than the sum total of the parts. So to understand such complex phenomena which are exhibiting a non-linear behavior, it is very necessary that we develop some models of urban growth. These models not only provide us understanding of the phenomena, that is the urban growth, but they also serve as a what if kind of a tool. That means we can develop various scenarios of urban growth in response to various policy measures that are taken by the development authorities. So in order to have a better understanding of the entire phenomena of urban growth, it is necessary that we develop some models of urban growth by which we can predict the future urban growth in response to the various policy measures. So I am going to discuss with you some of the work which we have done in this field of urban growth modeling. Of course, regarding urban sprawl, see, urban sprawl is basically a type of development which is characterized by low density scattered development, and this mainly occurs on the fringes of existing urban area, and most of the development is unplanned. The urban sprawl can be of different kind. Either it can be linear in fashion, it may follow a particular road or a major corridor or transportation corridor also. It can be leapfrogging, that means the development may occur in different pockets also, right? Or it may be dispersed also. So we are having different kind of sprawls, and in order to ensure a sustainable urban growth, it is very necessary that we should be able to mathematically somehow provide an answer to the various development pattern a city is undergoing during the last previous years, and in the future what will be the development pattern. So we try to simulate the growth of urban areas in the Doon Valley. You see, the Doon Valley, why we chose this study area is the entire urban population as per the 2011 census is 50%, 56% in the Doon Valley, which is quite high, and 76% of the Doon Valley population resides in the Dehradun urban agglomeration. So in the Doon Valley we are having a very concentrated type of growth, urban growth, with most of the population being concentrated in and around Dehradun, which constitutes the Dehradun urban agglomeration. So basically we have a private or a mother type of a primate city settlement system in which we have a main city and followed by other small towns. But most of the economic activities and the population concentration is in the Dehradun city only, right? And you see, Dehradun not only serves as a major educational, cultural and a service center for the entire Himalayas, basically the Garhwal region, but it also is a important administrative center also, with a number of institutions and research institutions situated in it. Because of this, you see the urban growth has taken place in such a rapid manner that it has stressed the existing infrastructure of the Doon urban agglomeration to a breaking point. So it was very necessary to have a study like what is the carrying capacity of the DUA, that is the Dehradun urban agglomeration, and if and what steps we can take in order to reduce the stress on the existing DUA. Keeping this in view, we tried to develop various growth scenarios in response to various policy measures for the entire Doon Valley. Now, this is a NIS3 sensor of the entire sensor image of the entire Doon Valley. It has a spatial resolution of around 23.5 meters, and this is the entire Doon Valley. If this is situated in the Uttarakhand state, in the northern part of India, and the Doon Valley is basically bounded by two rivers. On this side, west side, we have the Yamuna, and on the eastern side, we have the river Ganges. Right? And this is the Doon Valley. The valley is basically longitudinal in nature, which is around 72 kilometer long and around 35 kilometer wide. And you see, this is basically a longitudinal valley. The lower part, we have the Sal forest, and upper part also a large part is covered by the reserve forest. While most of the growth, that is urban growth, has taken place in this part. It is taking place in a longitudinal part. This is the Dehradun city, that is the primate city of this entire settlement system. Plus again we have got some other smaller settlements in this area, right? And what you see, this is, these are small seasonal rivers that come down, right? So the entire development is like this. With most of the, this is the Dehradun Valley, where Dehradun city, where most of development has taken place. So we want to predict if nothing happens, how the urban settlements will grow in the entire area, and if we generate some scenarios, how the development happen in this entire Doon Valley. See, it's basically a longitudinal valley. So the research objectives were, we want to explore the process of land cover change, and then we want to identify the variables which are basically driving the dynamics of urban growth in our study area. Or you can say we want to map the urbanization dynamics in our study area using remote sensing images. Then we wanted to project what are the future land cover scenarios in response to various policy measures, and also evaluate the influence of alternate policies on the future growth patterns. So this was the main aim of this entire study. Yeah, this again I am showing you an image of the Doon Valley, you see. Now, before we began, the first thing, using a remote sensing images, we have to classify this imagery into various land cover types, right? And then built up is also one of the land covers, and then we try to study the dynamics of these land covers over temporally or over a period of time using temporal images. So the classification we took was, the first class was the built up urban area. This consisted of areas which were located inside the Dehradun urban agglomeration, right? And the natural cover was basically substituted by artificial, often impervious long duration cover. So all built up area which was located or situated inside the Dehradun urban agglomeration was called as built up urban areas. Then second was built up non-urban areas. These were the land covers which were situated outside the Dehradun urban agglomeration. See, or basically you will say which were located outside the, in your study area you can say areas located inside the municipal corporation boundary, you may take them as a built up urban. Outside or the fringe areas you may call them built up non-urban. But in our case we have taken areas inside Dehradun urban agglomeration as built up urban, and built up areas outside the Dehradun urban agglomeration, that is called as DUA, have been called as built up non-urban, right? The third category was cultivated and managed area. That means the croplands, the orchards and plantation lying in Dehradun urban agglomeration and outside the both. All croplands, agricultural land, orchards, plantations, basically which were cultivated and managed areas. These areas were managed by human beings. So these have been classified under one category, that is cultivated and managed area. The other was the natural and the semi-natural vegetated areas. These included the forest, the shrubland, the grassland and the sparse vegetation. So you see, the vegetation was basically divided into two parts. The first being vegetation which was cultivated and managed, right? And the second was vegetation which was natural or maybe semi-natural, maybe along the water bodies, or maybe you see some, it may be along water bodies or maybe wetland. So these are basically natural and semi-natural vegetated areas which we are using in this present study, right? And the third was artificial and natural water bodies. So they included rivers, streams, canals, lakes, ponds. So we have basically classified the entire thing into five, you see, 1, 2, 4, into five categories. We try to classify the entire image into five land cover types. We have tried to classify the image. We have not gone much into deep into artificial, we have not differentiated them because our emphasis was basically on built up areas. So we have clubbed both artificial and natural water boundaries into one category. So using a list 3 image, we produced a land cover map of Doon Valley using the 5 classes which I discussed earlier on. So you can see this is the built up municipal, that means area lying with built up area lying under the Doon urban agglomeration, which we will call now as DUA. As an acronym we will call it as a DUA, right? So this is the area lying inside the DUA. These are built up areas or built up areas which are lying outside the Dehradun urban agglomeration. This is the cultivated and managed vegetation which consists of agricultural lands, orchard, plantations, and this is the natural and semi-natural vegetation which consists mainly of forest. They are all reserved forest area, mainly consisting of sal forest, right? So this image was done using a list image, that means it has a spatial resolution of 23.5 meters. This again, we produced a land cover map of Doon Valley for the year 2005. Again, we took a list 3 image of 2005 and again we classified into 5 categories, right? So if you see these images, you see, and you try to concentrate on this Dehradun area, you see slowly over a period of time this area has expanded very rapidly, right? And besides, if you see, some development has also taken place along the other settlements which are mainly situated along the roads. And you see, this is an image of 2000, using an image of 2009, we have made a land cover map of 2009. So if you see, if you just have a glances, see this area has expanded so much, while in 2005, you see, it was only this much. And if you go back, you see again it was this much. Here also you see, slowly with a period of time, you see, the area in the red, it has shown a very dramatic increase also, and some areas you see have also come up in this part, that is areas which are located outside the Dehradun municipal agglomeration. You see here they were less, but slowly the green cover has reduced, you see, and slowly these areas which we call them as fringe areas or peri-urban areas, they are located outside the municipal DOA but contiguous to that area only. See, we are having a lot of development inside the urban, inside the DUA area also, plus a lot of development is taking place in areas which are contiguous to the Dehradun urban agglomeration area. So if you take these multi-temporal images and you simply make land cover maps of different time periods, then using this imageries you can easily map the you see the urbanization dynamics. You see the dynamics, that phenomena easily you can understand it. But the next question is, we can monitor this dynamics of urbanization using this temporal imageries, but how do we model it? Can we develop a model by which we can explain this growth of urban areas then we can predict also the urban growth in the future area. So that is part 2. You see that this part is basically you have tried to model the urban growth, or you can say you have tried to model the urban sprawl. The next question is, can now we develop some mathematical equations, or we can develop a model by which mathematically we can explain this growth phenomena of urban areas and also then predict the growth in the future also. That is urban spatial growth modeling. So this, you see here graphically we have tried to explain how various categories have transformed from one category to other. How the transformation of categories, you see, has taken place. See from 2001 to 2005, what you see on right side is increase, and what you see in left side is basically decrease. And we also have put up a symbol, negative symbol here, which shows a decrease in a particular land cover, and this shows an increase in the quantity of a particular land cover class. So you see, although the cultivated and managed area has grown, the built up area has also grown, and the built up inside municipal area has also grown. But the category which has decreased is natural and semi-natural vegetation. If you see from 2005 to 2009, you will see here also the cultivated managed areas have grown, the built up has grown, and the built up, but the natural and the semi-natural vegetation has decreased over these years. So what we can try to infer from these two diagrams is the natural and the semi-natural vegetation has slowly transformed into agriculture areas, and these agriculture areas over a period of time have then transformed into built up area. So this is the process of land cover transformation which we are seeing in our process. Mainly it is natural and semi-natural vegetation to agriculture, and slowly the agriculture then changes to the built up. Of course, we may have cases where the natural and semi-natural may change to built up, and also the cultivated may also change to built up. See, if you see, now this diagram tells you the increase in the built up inside the municipal boundary and what has been the major contribution to increase in this built up, but inside the DUA area, that is the Dehradun urban agglomeration area. So you see, inside the Dehradun urban agglomeration area, basically we don't have much of a natural, you see, inside a municipal corporation area or urban agglomeration area, you naturally don't have much of natural vegetation. The previous diagram, if you see, they showed for the entire Doon Valley. So if you see for the entire Doon Valley, for the entire Doon Valley, the major transformation has been of the natural and the semi-natural vegetation to agriculture and then to built up or to built up within municipal area. But this shows you the land transformation process inside the urban agglomeration area. So inside the urban agglomeration area, it is basically mainly the cultivated and the managed areas which have transformed into built up. See, this diagram shows you what has been the contribution to the built up areas from various categories. So the maximum contribution to the built up area increase has been from cultivated areas. And in 2009 or 5-9 also you say, which I will call as T2, excuse me just a minute. If you see in from 2005 to 2009, again you see the same trend is repeated. The contribution to increase in built up area inside the municipal boundary or inside the Dehradun urban agglomeration has been mainly from the cultivated. So you see what is happening is inside the urban agglomeration or municipal boundary, it is basically the cultivated and managed areas, maybe orchard, plantations, or some agricultural land that is being slowly transformed into built up areas, right? So inside municipality you can say we are having a cutting up of a reduction in the amount of orchards and plantation. And if you see the contribution of change in the built up means areas which are situated outside the urban agglomeration. Earlier we discussed areas, built up areas inside municipal boundary, the main contribution to their growth has been from agriculture areas. But for areas which are outside the built up areas, outside the municipal boundaries, those areas increase has been at the cost of major contribution from the cultivated and the managed areas. You see, and a large proportion from natural and semi-natural also. So what we are finding is inside the municipal area, it is basically the agriculture that is a major contributor to increase in the built up area. Outside the municipal boundary or outside the Dehradun urban agglomeration area, it is basic both the cultivated and the natural semi-natural vegetation, which both are contributing to the increase in the built up area. That means built up area outside the municipal limits. Right? And this shows how the cultivated areas have grown. You see, the major contribution to increase in agriculture area is from natural and semi-natural vegetation, and plus negative shows some cultivated areas have transformed into built up municipal. See, so what we are trying to support is the same thing we are getting from our different diagrams. The thing is, built up areas are growing at the expense of mainly agriculture areas, and agriculture areas, they are basically growing at the expense of natural and semi-natural vegetation. So you see, by drawing this diagram, we can find out what is the land transformation process in our study area. Like in our study area, we found out it is mainly the cultivated area, natural and semi-natural vegetation, which is first transforming into cultivated areas, because we have a large contribution of natural and semi-natural to the growth of agriculture, cultivated areas. And then these cultivated areas are then transforming into built up areas, both built up inside municipality and built up outside municipality. And of course, some cases we also have cases where the natural vegetation is also transforming to built up area, but that is very less. Whatever we have discussed by charts, here we have tried to show you in a spatial format. Yeah, that was in form of a diagram. Now we have things more of in a map format, right? So you see, you can focus is very small, but you can see this is the cultivated to built up municipal. You see, inside it is basically agriculture which is changing, right? And you see the dominant class is natural and semi-natural vegetation, which is changing to cultivated and managed area. So you see here, outside the Dehradun urban agglomeration DUA, it is basically a large transformation is occurring in form of natural and semi-natural vegetation, which is changing to cultivated and managed area. So see, the same thing we are trying to now see both in a spatial format, in a map format, or in a diagram of a chart format we can see. So but you can see that these areas, basically these areas, a major transformation is occurring from natural and semi-natural vegetation to cultivated areas, and here also making, and basically inside the municipal area it is basically changing of cultivated areas to municipal built up. That is the dominant use that is taking place here, and this map is made for the time period 2001 to 2005. Again, for 2005 to 2009, you see, this process has now become more intense, you see. Earlier it was less, but now I told you the Doon Valley is undergoing a rapid pace of urbanization. So this process of transformation of, see, two processes have become dominant. One is natural and semi-natural to cultivated, and the other being cultivated to built up, you see. So these two processes are quite dominant outside the Dehradun urban agglomeration, but inside the Dehradun urban agglomeration, it is basically changing of cultivated to built up municipal, you see. So whatever the process we are seeing here, these process, you see the blue, the green and this magenta one, you will see this, you can read it out, cultivated to built up. These things have now become more intense. The process of land cover transformation has become now more intense with a rapid increase in the built up areas basically, see. So if you find on percentage format, this will be more compared to the older time, 2001 to 2005, 2005 to 2009 will be more dominant. Right? Now, see, till now you see what we have discussed is how using satellite imageries and in a GIS environment we can understand the process of urbanization, yeah, that urbanization dynamics, how we can understand and also represent it using different maps or charts also. Now second part is how can we model this growth? Can we try to develop a model to capture this growth process? So the first thing we have to do is we have to find out the factors which are affecting this growth phenomena. That means what are the causative factors which are affecting the land transformation process. Causative means what are the process which are causing this phenomena to occur. That is the what are the, or if you say some writers also called this what are the phenomena which are driving the dynamics of urban growth, right? So here we assumed some factors. They may not be total, but we have taken some, right? So we say the growth of built up areas in municipality mainly depends on 7 causative factors. See, 7 is not the end. There can be n factors, but for sake of simplicity, we have taken only 7 factors, 7 causative factors. The first factor is, what is the distance of a particular piece of land from a major road and from a minor road? Because accessibility to road is one of the major factors that drives the urban growth process. The second we have taken is, what is the amount of built up cells in the neighborhood? You see, if there are number of houses are built in a neighborhood, that piece of land has a very high probability of development because all the infrastructure facilities like sewerage, electricity, piped water supply, small shopping center, local a tot lot for children, that will be available in the easily available neighborhood. So if a piece of land is near the road and a lot of built up area or a lot of built up houses are there, in the neighborhood of that piece of land, then that piece of land has a very high probability of development. So these 2 factors we have taken in a study. The first is accessibility, the second is local level facilities, the third thing is how much amount of land is available, agriculture and semi-natural. You see, even though a particular piece of land is maybe accessible, may be very near to a road, it may have a number of built up a number of houses in the surrounding, but that piece of land should be vacant. Then only it can develop into a built up. So the land supply also we have tried to incorporate by in the terms of amount of agriculture land in the neighborhood, and the second being amount of natural and semi-natural vegetation in the neighborhood, right? And the fourth factor which governs urban growth is the slope of the area, right? And whether it is south facing, north facing, you see, east facing, west facing, because that also decides the amount of sunlight which will come into your house, right? So the 4 factors basically we have taken which decide whether a empty piece of land will develop into a built up or not are, the first is accessibility, that is measured in terms of distance from the major roads, distance from the minor roads. The second is what are the local level facilities available, that means amount of infrastructure support in the neighborhood. The third is what is the land supply. If you have more land supply, more development. If you have land supply, is less development. The third is the topography of the area, that we have measured in terms of DEM. We all know digital elevation model. I will not elaborate on it. And the third is the aspect. So we have taken two things, the aspect and the DEM. Corresponding to these factors, we have generated road. This map shows the Euclidean distance. Remember, it shows you the Euclidean distance of each non-built up cell from the nearest road. Right? The Euclidean distance of each non-built up cell from the nearest road. So what it shows you, this is the Euclidean distance of each non-built up cell from the nearest road. This you can generate in any GIS software. Any software you can use, it can give you a Euclidean distance map. This is the digital elevation model we have used, right? See, this area is more or less having the same flat area, because this is the foothills basically we have, and this is the hilly part, and this is basically the plain area. This is the valley, you see. If you see here and see, this is the valley, how it becomes. Right? And this shows the amount of agricultural land in the neighborhood of each cell. See, the larger the amount of agricultural land you see, maybe you can say the less the infrastructure that is available, right? So I have not shown all the maps, I have shown you some maps to give you idea like how we have gone about generating the maps, and all these maps are in raster format. You see, this entire modeling exercise was done in a raster format. So the format is raster. Similarly, we have taken 8 factors or 8 causative factors which affect the growth of built up area, that is areas situated outside the municipality. The first being accessibility. The second being how far the particular cell is from the town or from a small town. You see, if a piece of land is situated just, you see, contiguous to the municipal area, then that cell will develop very rapidly. But if it is situated, suppose 5 kilometers from the city boundary, then the development potential goes down. So we have taken 2 more factors. The first is distance from other towns and distance from Dehradun urban agglomeration, that is DUA area. The third is the amount of land available, that is the amount of agricultural land in the neighborhood, and the amount of natural and semi-natural vegetation in the neighborhood. And the fourth factor is the DEM and the aspect, you see. So you see, we have taken these 2 factors, we have increased, because a piece of land situated outside the municipal area, the growth is also governed by the fact what is the distance from the city or from the nearest town. So 2 more factors we have increased it when we are taking the causative factor for determining the growth of built up areas. So this is a map which shows, see, these are the distance from other towns. We have not taken distance from the Dehradun municipal area, but we have also taken the distance from Dehradun municipal area in separate map. In a separate map we have shown the distance from other major towns located inside the Doon Valley. Yeah. And this shows the distance of each pixel from Dehradun urban agglomeration. The previous map showed the distance from not Dehradun urban agglomeration but from other small towns. Now for agriculture also we have taken some factors. The first thing is what is the amount of natural and semi-natural vegetation in the neighborhood, because land natural and semi-natural is only transforming into a agriculture, right? What is the amount of agricultural land in the neighborhood? Distance from water bodies, because for irrigation you require regular water supply. The topography and the aspect, right? So these 5 factors we have taken when we are trying to find the potential of a land to develop for agriculture. Of course, you see, You can take more factors also, but this was a case study, so we have limited ourselves to 5 factors only. But again I am emphasizing the point, this is not the end, you can take more factors as per your study area, right? But you see, now we have got a map which shows how the development has taken place. We have generated maps which show, which are corresponding to the various variables which are driving the urban growth. How do we link this development and the variables driving? So the dependent variable is the urban growth and the independent variables are the factors which are driving the growth. How do we link it? You see, you can say we can do a regression analysis between them, but again as we discussed earlier, urban growth is a non-linear phenomena. So whether linear regression can capture that dynamics, that is also questionable. Secondly, you see, the model calibration, like which equation you should fit. Should you try to fit a second degree equation? Should you try to fit a third degree equation? Then how to find the equation parameters so that we can model that phenomena accurately. That are two things. So the second point is, the first point is, there's a lot of subjectivity in this modeling now. Secondly, model calibration is done by trial and error. Third, for a person not having much of a mathematical background, this phenomena becomes very complicated and confusing. Thirdly, some models are also non-spatial in nature. The results you may get, but how to show those results in a spatial format, because we are dealing with urban spatial growth modeling. So the results have to be shown in a spatial format. And third, some models also work at a very gross level, but you want to show the results at a micro level, how to do this. So these were some of the gaps in urban growth modeling, right? So here we try to incorporate artificial neural networks into this phenomena. See, the equation was, we had land cover change, which was the dependent variable. We had independent variables, that were the causative factors, like distance to road, distance to nearest built up, amount of built up in the neighborhood. The problem was how to find a relationship between the dependent variable and the independent variable. This process was quite complicated, and the calibration, model calibration was also very tedious process. So here we have tried to use artificial neural networks, called as ANN in short, for for finding the relationship between these dependent variable and the independent variables. What the ANN do this is, just like human beings, you see, they are very good at learning patterns, you see. So these artificial neural networks, they can learn the pattern from the database. You see, if we give them some training data sets, they themselves can learn the dynamics phenomena or the patterns, they can learn directly from the data set. And in this way, the human intervention which you told earlier is reduced. The approach is less subjective, it's more of objective in nature and time consuming, because artificial neural networks, they themselves pick up the pattern in the data set. So if we give them data set like these are the factors and development has taken place, then the pattern itself is picked up by the networks from the data set. So this reduces the human intervention part, you see, and makes the approach more objective. And secondly, ANN are very good at learning non-linear patterns also. So that is why we have tried to apply artificial neural networks in urban spatial growth modeling, right? ANN, if you see, you can refer to any standard book. We are not going to discuss much, but I am just will discuss how we have applied artificial neural network to simulate urban growth, right? See, as I told you, the ANN, they are able to learn the patterns directly from the database and reducing the human intervention and making the approach more objective in nature. They can work on different data types. They can solve highly non-linear problems. And secondly, they make no assumption regarding the distribution of data. The data may follow a normal distribution, it may not follow a normal distribution also. So these are the advantage of using a artificial neural network, right? So what we try to do is, first we have generated the 4 maps. We have normalized these maps from 0 to 1. So how do we normalize? We divide each value by the maximum value. So all values will be between 0 and 1. Now we know if a pixel has got these values, then the output value should be 1. Because using 2001 and 2005, if a pixel changed from non-built up to built up, we called it 1. But if the pixel remained at non-built up, we called it 0. So we say, if this is the cell values, the cell changed from the cell values 1. That means if this is the attributes of a piece of land, that piece of land will change from non-built up to built up. But if these are the attributes of the land, the piece of land will not change from non-built up to built up. In fact, it will remain as non-built up only. So we have got the values, we have got the desired results. The problem I discussed is how to find a link between these independent or driving variables and the desired output. This thing is normally done by a artificial neural network. You see, the artificial neural networks provides you a link between these two values. So what we do is, in an artificial neural network, we have got different layers. We feed in the data and we get a result. Then we compare this output with the desired result. If the error is more, again we feed this error into the network and we keep on doing this iteratively until the error between the desired and the actual results comes down to a acceptable limit. Okay? And there are a number of training algorithms available, but in this particular approach we have used the back propagation learning algorithm, which is a very industry standard and available in a number of softwares. So what we do is, using GIS and remote sensing, we generate a spatial database, urban spatial growth map, which I told you. We take some sample out of it and we give this sample to the artificial neural network and we say, if this is the attributes of a particular piece of land, attributes means distance from road is this much, amount of built up in the neighborhood this much, all those things. This piece of land in the past changed from non-built up to built up. If this is the attributes, the land remained as like that only. Then we feed this training data to the network and we keep on training it unless it begins to learn the patterns, like if this is the input value or this is the attributes, development will occur. If this is the development value, development will not occur based on the old time series remote sensing data. Once we say the network picks up the patterns, we say the network is trained and then we give up the entire data set to it and then it tells us a map which shows, and using this you see we can simulate also in the future, like in future if this is the attributes where the development will take place, if this is the attributes of piece of land where the development will not take place. So based on this we have generated various scenarios. The scenario 1 is, suppose the development of the city continues as it is happening now. That means the business as usual means nothing, no action is taken and the city grows as it is growing now in the future. And secondly, you see, after the Kedana tragedy, the government has proposed a law that no building activity can take place within 200 meters on both sides of the river body. So we say, suppose no development is allowed 200 meters on both sides of the river and the city continues to grow as it is growing. This scenario is normally called as business as usual. What will happen? So we say in future most of the development it will take place in the south of the city and some development will come up here also, right? This is the future scenario for 2027. if growth goes on as usual. The second scenario is, suppose suppose we have a policy that no, we will have a hierarchy of nodes. We will not have a growth concentrated in one place, but we will develop a hierarchy of development nodes. Then how the growth will take place? As per that scenario, the new hierarchy growth will take place in this part of the Doon Valley, that is basically the western part of the valley, and some development will take place, but no development will take place basically in this part. So most of a new urban node, basically it will occur in this, and of course no construction will be allowed within 200 meter of river body, right? The third scenario is, now if we say no, we want that the Dehradun should develop, instead of a hierarchy of node, we want it should develop as a single node. We should have a high density development located around the Doon city only, so that most of this area remains as open. So if we want to have a very edge kind of a growth, what will happen? That means if you want to develop a edge growth, then most of the growth then should take place in this area. So if you want to have a high density growth, then the proposed growth will be in this area. So see, what we have developed is, we are trying to simulate the future urban patterns in response to various policy measures based on empirical data sets, right? And using artificial neural network, we have tried to capture the growth pattern and then simulate the future growth in response to various policy measures. You see, now you see, till now we are working only for Doon Valley, but now using a data sets that is called as nighttime data sets, you see, what you see as bright is the amount of light that is captured by the satellite in the night. So this is the brightly lit areas are cities, you see. So this is called as nighttime data, because it captures the lights coming from the cities in the nights, right? So you see, this is Delhi, this is Calcutta. So here we have tried to simulate broadly, very broadly, what will be the growth pattern in the entire Indo-Gangetic plains. You see, this is the entire Indo-Gangetic plains, what will be the development pattern. Here, as I told you, we are trying to do this modeling at a very coarse resolution. So we have taken some factors like, what is the per capita income of each state, what is the topography, that means what is the least surface, least cost from traveling to district road. You see, you may be near to the road, but the terrain may be such that making a road will be impossible. So we have tried to use the least cost surface, where we have also incorporated distance from the road along with the topography between a piece of land and the road. You see. The third thing is the accessibility. The fourth is the level of infrastructure. See, cells nearer to class 1 cities have got a high population. Class 1 cities means cities having a population of more than 1 lakh as per census of India, right? They have a higher potential, distance from class 2 cities, distance from metro cities, and the local infrastructure. So using these factors, we have tried to model urban growth, but the model we have used here is basically the cellular automata model, that is called as the CA model. We have got different models of urban growth. Previously we are using a model that were basically based on artificial neural network. Here we are using a model that is based on cellular automata approach. Right? So these are the various factor maps we have generated: the per capita income, the equivalent distance from national highways, what is the equivalent distance from district roads for the entire Indo-Gangetic plains using the nighttime data, and the last is the least cost from the district road, right? So like this, just to give you an idea, these are the maps which we have done. Then using cellular automata modeling, we have simulated the growth for 2008 and we have compared it with the actual built up areas in 2008, because this helps us to validate our model. You see, if the model is not corresponding to the actual growth, that means we either have to incorporate more factors or make some changes in the model. So we have simulated, using a CA model, we have simulated the built up area for 2008 and then we have compared our simulation result with the actual results and we have tried to validate our model. Right? And here we have tried to simulate the urban growth for 2020 for the entire Indo-Gangetic plain. You see, these areas we say, as per the model, they are having predicted to have a high growth in the built up area, right? So you see, in a modeling approach, the remote sensing is basically providing you data, GIS is providing an environment to carry out the modeling, and then you can apply various modeling technique in the GIS environment, artificial neural network, cellular automata model, to simulate. You see, the main purpose of this is, can we somehow try to simulate the future growth patterns so that it will provide a rational basis for the urban planners on which they can base their decision. So in the end, I would like to summarize is, the ANN helps to reduce the calibration time and subjectivity in modeling exercise and modeling process. A GIS is used for handling of spatial data, basically to obtain spatial site attributes and training data. And ANN is basically used to reveal the relationship between the driving variables and the urban growth. See, GIS provides you data and ANN provides you a link. Right? So this is just an overview of work we have done, and thank you for your attention very much. And for the queries, you can give a mail to me, or you can give me a ring, whatever is feasible. And this is all. Thank you very much.